Assalamu alaikum warahmatullahi wabarakatuh. Today we'll continue doing chemistry Regent for August 2018. We are doing part B2. Now, show a numerical setup for calculating the percent of composition of oxygen. So now, here I have 3 oxygen. The total amount is 100 O2. So the percent of composition exists in the reference sheet last page. Percent of composition equal to percent of composition equal to the part mass over the whole times 100. Now, the oxygen is almost 16, and you can find that also in the reference sheet. Here, oxygen is molecular weight over there, so it's almost 16. 3 times 16 is 48, so it's 48, and he give me the molecular weight by 102 multiplying by 100. So that's the way to find the percent of composition of oxygen in aluminum oxide. Okay. Identify laboratory process used to separate liquid mixture. So liquid mixture of methanol and water based on different boiling points. So when I do a liquid mixture with boiling point, I use distillation or distillating. Okay. Question number 53. Explain in terms of subatomic particles why the 3 isotopes represent the same element. So because they have the same number of protons. They have the same number of protons, and number of protons is the ID for the element. Okay. Now state the number of the valence shell in isotope D. So isotope D, the number of protons equal to the number of electrons. So that's a proton, that's an electron. So I have 12 electrons. When I'm going to distribute them, it's 282. 282. And the valence electrons are the last one, so it's going to be 2. It's going to be 2. Okay. Compare the energy of the electron in the first electron shell to the energy in the second electron shell. So as we know, the energy levels to jump up, you need to add energy. So the energy for the second shell is higher than the energy of the first shell. So this is the same case for the electron. So the electron in the first shell is going to be lower in energy than the second shell. Question number 52. Group 2 in the periodic table. This is group 2. This is a 1. Okay. Group 2 in the periodic table can be compared in terms of first ionization energy, electronegativity, and other general properties. So he's talking about the trend, the periodicity, and the trend. Describe in general the trend of electronegativity in middle. Consider an order of increasing the atomic number. So if you're looking here, the beryllium was 22, after that 282. So here's the atomic number increase as you go down. As you go down, what's going on? The electronegativity decrease. Why? Because I'm going to have more shells. The radius increase, and the ionization energy decrease. Why? Because the electronegativity increase, so the ability to attract the electrons are less than the other, and at the same time the radius is less. Okay. Now explain in terms of electron configuration why elements in group 2 have the similar chemical properties. So chemical properties, if you're looking here, the valence shell has 2. Valence shell has two. So according to the configuration, the valence shell or the valence electron are two, and in the chemical reaction, they participate only by the electrons of the valence shell. Electrons of the valence shell. So that means they are going to have the same chemical properties. The same chemical properties. Explain term of atomic structure why barium has lower first ionization energy than magnesium. So if you're looking here, that's the magnesium, that's the barium. As I said, so electronegativity of magnesium is higher than electronegativity of barium. The radius for barium for magnesium is less than the radius for barium. So the ability of attracting and the size of the atom making it making magnesium need more higher energy than barium. Okay. A saturated solution of sulfur dioxide is prepared by dissolving sulfur dioxide in 100 grams of water at 100 Celsius and standard pressure. Determine the mass of sulfur dioxide. So I'm going here, I'm going for the chart. Okay, here is it. And I'm looking for sulfur dioxide. Here is the sulfur dioxide. So he said at 10, and that's going to be approximately around 15, 16. We have range, so don't be scared about that range. So around 15, 18. Okay. Now, based in table G, generates a relationship between the solubility and the temperature. So if you're looking here, here's the temperature. So as the temperature increase, what's going to happen? You're seeing the chart going down. So the solubility decrease as the temperature increase. That's the relationship between both of them. What describes the solubility of sulfur dioxide when the pressure is increased? That's one trend of the solubility. As the pressure increase, the solubility increase. As the pressure increase, as the solubility increase. Okay, increasing pressure, increasing solubility. That's one for the 5 rules we took in the solubility trend. Now, question number 62 through 65. Starting as solid sample. So now we have a solid sample. That's at the beginning. Until the entire sample of the sample is gas. So that's a curve. So here it was solid. After that, solid and liquid. In that case, it's going to be liquid. After that, it's going to be here liquid and gas, finishing by gas. So what does it mean again? At A, I have solid on. At B, I have solid and liquid. At C, I have liquid on. At D, I have liquid and gas. At G, and have gas on. Okay, so here it's going to be the phase is solid. Here the phase is liquid. Here is the phase is gas. Now we understood the chart. Now what he's asking, using the key in your answer booklet, draw a particle diagram represent the sample in the interval EB. So he wanted the interval EB means it's solid. And he said at least 6 molecules. In solid, the molecules are connected in a crystal shape together. Like that. Or I can make it like a pyramid, like that. Okay? Now, compare the average kinetic energy in BC to DE. So in BC, here has less kinetic energy than D. So less here and here is great. Why? Because in that case I'm going to start to have gas. And gas has more kinetic energy and moving randomly. And if you're looking here, I increase the temperature. Increasing temperature means I can increase the heat. Increasing the heat means I increase the energy. Increasing energy of the system means the upper level is higher in energy than the lower level. Question number 64. In your answer booklet, temperature that indicate the boiling point. So the boiling point is here. Why? Because this has liquid and it's going to turn to gas. So that's the temperature that steady has both phases. Okay. Question number 65. Set evidence that indicate that the sample undergoes only physical change. We still have the same. We still have the same. So same metal. I don't have any new material. Since I don't have any change in the material, so I still have the same element. Since I have the same element means it goes through a physical change. That's the end for that part. Should you understood. Assalamu alaikum wa rahmatullahi wa barakatuh.